Is it recording? I think it's recording.
Yes, ma'am.
Yes, ma'am.
Okay. Thank you. Guys, I'm sorry. When I get distracted, I become very distracted very easily. I apologize. So we have a unit circle like this thing here. I don't know what Teams is doing now to me. Like this thing here. Why is it here? Thank you. So we have a unit circle. Let me just draw quickly. This is from our last week. If you don't remember, please go back. And we know that our unit circle points, this is 1 and 0. This is 0 and 1. And then this is what? This is, what's this? -1 and 0. And this over here is 0 and -1. And we said that we will not use degrees in for pre-calculus. We'll use 0 degrees, 0 radians, which is then 0 degrees. Then pi over 2, we call it 90 degrees. Pi, we call it 180 degrees. Then 3 pi over 2, that's 270. And 2 pi is equals to 360. Now, we are saying that when we draw, before that, we said that there is a relationship between a point, which is x and y, our terminal point, meaning this point over here, and any other point that I choose on the circle, like any other point that I choose on the circle. We said the relationship is that the first value represents cos of t, and the second value represents sine of t. So we then go back and say, okay, so how did we work with this? So we're going to use the unit circle for us to be able to draw the sine and the cos function. So that's where we start. We then say, okay, fine. I know that my period for sine and cos is 360. So that's what we have learned, isn't it? That period for sine and cos is 360. But what is 360 in radians? We know that 360 is what? Pi over, it's 2 pi. That's what we said. Now, we know that when we are going to draw, if we have a Cartesian plane and we're about to draw our sine and cos, right? We know that this part over here, guys, this small block is irritating me. Sorry. Now, this part over here, we know that this is y and this is x. Right? So we can't just draw and divide and whatsoever. So meaning that we need to divide the period by 4. So we start from 0 and go to 2 pi. Right? Now, for us to be able to divide this interval so that we can draw our sine function, let's start with y is equals to sine t. Sine t. So meaning that for us to draw a sine function, what we're going to do is, we know the period is 4. So then we say, okay, fine. Let's call it the interval of division. For example, for now, let's call it the interval ID, the interval of division. We take the period divided by 4. In this case, our period is what? Our period is 360 in radians, because we are working in radians. Our period is 2 pi. So then we say 2 pi over 4. And we know 2 pi over 4 is the same as pi over 2. Are we all together there? Same page, guys, for now. Yes or no? Hello?
Yes, ma'am.
Okay.
Yes,
Thank you. Okay. Now, so we then say, okay, 2 pi over, what's this? Pi over 2. We know pi over 2 is what? Is 90 degrees. Meaning that we are focusing in this part over here. Now, when we are drawing the sine graph, we start always at 0. Even when we were doing our terminal points and whatever, we always started at what? We always started at 0 and 1. 1 and 0, which is then we always started at 0 radians in this case. So then it means that even in the Cartesian plane, that's where we're going to start. But we know the relationship of the terminal point as well as the sine and the trig function. So meaning that the second point in that particular terminal point, in all these points, even the ones for pi over 4, pi over 6, the second point is actually used for what? The second point is actually used to draw the sine graph. So meaning that we're going to use this point here, we're going to use this point here, we're going to use this point here. All the y values will be used to draw the sine graph. So let's do that. Right? Now, we said we divided by 4. We divided by 4. So let's go write our interval. So from 0, how do we write our interval? We say, okay, from 0, we then add pi over 2. 0 plus pi over 2, what do we get?
Pi over 2.
Thank you. We get pi over 2. So pi over 2 plus pi over 2, we get 2 pi over 2, which is pi, isn't it?
Yes.
Which is the same as pi. And then plus another pi over 2, we get 3 pi over 2. Plus another pi over 2, we then get this 2 pi over 2. Right? Because then we say, okay, plus 3 pi over 2 plus pi over 2, we then get 4 pi over 4 over 2, sorry, which is the same as 2 pi over 2. Are we all together at that point? Yes or no?
Yes, ma'am.
This part is distracting me, this small box here. Let me do this. Good. Now, let's go back to our unit circle. At 0, what is the value at 0? What is the value of y at 0?
0. 0.
It's 0. Thank you. So meaning that we are here, right?
Yes.
Now, at pi over 2, what is the value of y there? At pi over 2, look at pi over 2.
1.
What is the
1.
value of y? It's
It's
what?
1.
It's
1.
1. So meaning that it will be here. At 2 pi over 2, which is pi, what is our value of pi there? Of y? It's 0.
Negative 1. 0.
And then at 3 pi over 2 on the unit circle, what is the y value there?
Negative 1.
Negative 1.
So it's negative 1. Then at 2 pi, what is our y value there?
0.
0.
0. So then this is your, so when you join this is your sine graph. Did you see how I drew it, guys?
Okay, yes, ma'am. And now I see the relationship between the pi and the.
Thank you. So then the unit circle will help you to actually do what? Will help you to draw. Yeah, this block is. The unit circle will then help you to draw what? To draw the sine graph as well as the cos graph. Can we try the cos graph?
Yes.
Yes, ma'am.
Let's try the cos graph. Where do we start?
Find the period again.
Yes. So we find the period. We know the period is what? Is also 2 pi there. And then we divide the period by 4. We divide the period by 4. Ooh, I don't know what Teams is doing now, having this small thing block here. So we then divide by pi over 4. We also get that. Then we go and write our interval. This is our interval from 0, pi over 2, 2 pi over 2 and whatsoever. Now, then we start at 0. What is our cos value at 0? At 0 degrees, what is our cos value?
1.
1. Well done. So meaning 1 is here. So then let me choose a different color. So our cos value is 1. So it starts here. At pi over 2, we go back. Here's pi over 2. What is our cos value?
0.
Thank you. So we come here, 0. And then at pi, what is our cos value?
Negative 1.
1.
Negative 1, which is here. Then a 3 pi over 2,
0.
0. We know that's here. And then a 2 pi is what?
1.
1.
1 here. And that is our cos function. That's our cos function. Do you see how we draw cos and sine?
Yes, ma'am. Ma'am, I also have a question.
Yes.
Ma'am, I remember in high school they taught us about the amplitude, like stretching. Whereas you see where upper ma'am okale kuti the y value starts at 1 and then it goes to 0. Where in
Yes.
high school it was 2, it would start at 2 and then it would go to 0 and then it would go out to -2, jalo jalo. I forgot what it's called. I forgot what the formula is called. So can you please show us kuti in that instance how like Natin?
I understand what you mean. Listen to
Yes.
this. I was expecting that question. Last year, someone said, ma'am, your sine function is like this. Right? But Mina in high school, I had a sine function that is like this. Do you see that? What's the difference? So let's go to our work, then I'll answer you when we get there.
That the sign leaps over to the negative side.
Yes. So what is that? So let's go to our work, then I'll explain that. This is actually what we're going to learn today. Now, we have learned, let's just summarize. We have learned that sine starts from 0, goes to 1, goes to 0, goes to -1, and goes to 0. This is our sine function. We have learned that one, isn't it?
Yes, ma'am.
And then we have learned our cos function. Where did our cos function start? It started from 1, went to 0, went to -1, went to 0, and went to 1. It was like a parabola. That is our cos function. Are we all together?
Sine.
Yes, ma'am.
That's what you need to know for sine and cos without a calculator. Now let's go to our work. If you understood that part, then it means that the next part will be easier.
Ma'am,
Yes.
why did we divide our period by 4?
It's because there's a relationship between a unit circle as well as the what's this? A unit circle as well as the Cartesian your Cartesian plane in which you draw your x and y. And your unit circle is divided into how many parts? The 1 and zeros. They are divided into 4 parts, which is the 0 degrees, the 90 degrees, the 180 degrees, the 270, and the 2 pi. That's why we are dividing the interval by 4. So that relationship, we use that relationship to draw the graph.
So it will only apply to cos and sine.
Yes.
Okay.
As long as you perfect cos and sine, second cos and cot and whatever, we'll see it in future, which is in the next hour or something. So let's look at trigonometric functions. Now, graph of sine and cosine. We know how to draw the graph of sine and cosine without using a calculator. And then they say graphs of transformations of sine and cosine. You remember your transformations from chapter 2. Same applies here. Now, using a graphing device to graph trigonometric function, we're not going to do that section. So they say the graph of a function gives us a better idea of its behavior, of course. So in this section, we graph the sine and cosine function and certain transformation of these functions. So graph of sine and cosine. So they say here, to help us graph sine and cosine function, we first observe that these functions repeat their values in a regular fashion. In other words, if you have, remember what we said last time, we said that if you have t is equals to pi over 2, right? The value, the terminal point for t is equals to pi over 2 will be the same as the value for terminal point of t minus pi over 2 and will also be the same even if you just say pi over 2 plus 2 pi. Do you remember that? What we said in the first class? We said that if you have a terminal, if you have a value of t, the distance, which is equal to maybe pi over 3, if you add 360, I mean, not 360, if you add 2 pi or subtract 2 pi, you don't change anything, because at the end of the day, in the unit circle, you'll end up in the same position. Do you remember that, or you forgot, guys?
We remember.
Thank you. So now they say, in other words, if I add t plus any to pi in such a way that n is an integer, meaning n can be 1, meaning you have added t plus 2 pi, n can be 5, it means 5 plus that, that's t plus 10 pi. For any integer, you still get sine t. That's what we talked about in our previous section. Same applies for cos n, which is equals to cos t. So then they say that's the sine function and the cosine function are periodic according to the following definition. Here's a definition of a periodic function. They say a function is periodic if there's a positive value of p, such that if you put t plus p is equals to f of t, then for every t, then you get f of t for every value of t. Does that definition make sense? Can I move on?
No.
Hmm?
Does not make sense.
So they are saying that if I have a function, for example, like y is equals to sine of x, right? If I take this and then I put a value p, let's call it a value, a positive. You see here they're saying a positive number,
Yes.
right? If I put a positive number, sine of x plus 2 pi, and we know that sine of x plus 2 pi is the same as sine of x, right?
Yes.
If I can get the original function with that positive number, then we're saying this function is periodic with a value of p. So its period is p. That's what they're saying. So for example, if p was not a positive number, let's say p was just any value. If you have y is equals to x squared, right? Now, if you substitute inside x squared, you say x plus 0 squared, you still get what? You still get x. If p was a 0 here, then we say our period is 0. Because I still get the function even if I add that value. But in this case, they are not saying 0. They say, but the value should be p, should be a positive number.
Positive.
So if you have, yes, if you have any positive number such that you put inside and get the original function, then we say that function is periodic with a positive number p. Makes sense as now, yes or no?
Yes,
Yes.
makes sense.
Good. So now they're saying that sine is periodic with, because if you say sine x plus 2 pi, you still get sine x. Sine x minus 2 pi, you still get what? Sine x. Therefore, it means that 2 pi is the period of what? Of that function, of sine. Same applies to cos. That's what they're saying. Okay. Now, let's move on. So they say the least such positive number, if it exists, is the period of that function. That's what we are saying. If there is such positive number exists, then that is the period of that function, meaning that 2 pi is the period of sine and 2 pi is also the period of cos, because of this relationship over here. Their value, that value of p is this one. Here's the value of p, this value of p. This is the p. So meaning that the period of sine and cos is equals to 2 pi. That's where the whole thing comes from. Now, there's something that you need to be very careful. If f has a period of p, then the graph of a function of f on any interval of period p is called one complete period. Did you see this word somewhere? Hello?
Yes.
Thank you. Let's look at that. So meaning that what we have been drawing, for example, for the sine graph, we said from 0 to 2 pi, right? We said it starts from 0, comes at that, comes at there, comes at there, comes at there. Do you see? I even claim the shape. I know the shape. So this is called one complete period. Now for cos graph, so this is sine of x. For cos of x, this is one complete period where you know it starts here. It starts here, comes here, comes here, comes here, and comes here. It's like a parabola like this. We call it one complete period because it has one period here, 2 pi. Are we all together there?
Yes, ma'am.
So let's move on. So they say so the sine and the cosine function repeat their values in any interval of length 2 pi. So what they mean is, once I'm done here, if I want to draw another period for this, because this is only one complete period. If I want to draw another complete period, it means I have to come here at 2 pi and add p. In this case, our p is what? Our p is 2 pi. So if I add 2 pi by 2 pi, I get what? 4 pi. Do you see that? Now I'm now going to draw another period. So meaning that where does sine start? Remember, you are dividing your interval now. Here, you know that cos starts from here. It comes here. It comes at the bottom, comes here, and comes here. Then you have extended to another period. Does it make sense, guys? Yes or no?
Yes, ma'am.
You can also extend it to the left-hand side as well. That's why in grade 12, you'll have something like a sine function like this, because it has it's either had 3 of different complete periods. So meaning that for one complete period, it's the complete sine. It's a complete sine function. This is a complete sine function in one complete period. These are 2 complete sine functions in what? There are 2 periods here. So there's a first period here and there's a second period there. Did I lose anyone, guys?
No.
Okay. So now they say to sketch the graph of, so here they're just sketching the sine and the cos function here, right? But then they're choosing points, just how you'll choose points with your calculator or just choose points. So they say, okay, fine, we choose these points and then we draw a table and this is how we use the table. So I'm saying let's not use the table method because in our work, we're using no calculators. So we'll do what? We'll actually use the unit circle, and we did use the unit circle. This is the shape we got for sine, isn't it?
Yes, ma'am.
Yes, ma'am.
Yes.
Mm.
So they say now we use this information to graph the sine and cosine function. So here from 0 to 2 pi, if you want to extend this graph, meaning that in your assignment, okay, I don't like giving out answers now. Should I give you answers?
Yes.
Yes.
Yes, please.
Please, ma'am.
Yeah, I'll be in trouble. Okay, listen to this and listen carefully. In your assignment, if it says draw to one complete period, I need to see something like this. If I see something like this, then it means you are wrong. Are you happy with the answer?
Yes, ma'am.
All righty. So meaning that if it says draw one complete period, it's like you jumping 3 times. Those who are doing aerobics, if they say uppercut or punch 3 times, that's one complete section. And then they say left, punch 3 times, that's another complete section. It means that you are doing a complete period. That's sine. Do you see that? That is sine. Now, how can you look at this graph? Another answer now for the assignment. If they give a graph like this one over here, and they tell you find the period, find the what, find the what, find the what, you go and check a complete period. Are we together? I'm giving you another answer.
Yes, ma'am.
You go and you know sine is always like this. This is one complete period of sine. Do you see that? Go and
Yes.
check this shape. Do you see that if I draw a line here, there's my shape. Do you see that?
Yes,
There's my
ma'am.
sine. There's my sine graph in here. So meaning that I check the distance from here to here. How can I check a distance from here to here? Do you see that? I then say, okay, I know this is 2 pi and I know this is 0. So then I say 2 pi minus 0. So my period for this graph is what? Is equals to 2 pi. Because I know the shape. Where is the other shape of a sine? I know sine starts from, I can also do from here to there. Do you see another complete period of sine?
Yes.
So then I go check the distance from here to there. So this is what? The period is equals to 4 pi minus 2 pi. Which then gives you what? 2 pi.
2 pi.
Do you see how to find the answer for that graph that is in your work?
Yes.
Danko. So
Yes,
then
ma'am.
that's how you find what? That's how you find the answers. Now okay, I'm moving too forward. So meaning that they've extended from 0 to here. Is that a complete period of sine? Guys, is that a complete period of sine?
No.
No.
But it looks like a complete period of what?
Cos.
Thank you. So that is why in the assignment or in the exam, don't tell anyone, in the assignment or in the exam, sometimes they can tell you that depending on where you choose a complete period. For example, if I cut here and I knew this point here and I cut here, do you see that this is one complete period of a cos? Do you see that?
Yes.
Even if I cut here and here, this is a complete period of a cos. So meaning that if you are given a graph, you can either have a sine function equation or a cos equation in one graph, depending on where you cut. So check which points are you given. Check which points are you given. That's why the assignment says that, ooh, Lord. Just allowed. That's why you will see in the notes given that they will say the above graph defines y is equals to cos something or y is equals to sine something, because depending on where the points are. So if you are able to identify one complete period, because you know what a white complete period is, then you are able to answer. So meaning that everyone now know that they need to draw one complete period of what they have been given. And if you draw something like this and it says one complete period, I'm going to put a 0. And if it was a physical paper and you were here, I was going to zip you. Are we all together?
Yes, ma'am.
Yes, ma'am.
Thank you.
No, ma'am.
Yes. Where's the no?
Ma'am, are you saying from 0 to minus negative? Is this negative? This side, ma'am.
Which side? This side here. Yes, negative pi.
Oh,
Yes.
negative pi. Are you saying it's a cos? It's a cos graph?
I am saying it's a cos graph if you cut it here. Look at this. If you cut it here, do you see that? Here,
Ma'am,
somewhere here.
Okay, I get it, but it is half. Oh, if you cut it before
Yes.
0, eh?
Yes. If you cut it
Okay.
just after 0 and you look at this small curve here, that small curve looks like this. And we know that's a cos function.
Yes, because if we cut it from, we take it from 0. This the cos graph should start at 1. So if we take it from 0, there are some of the points missing. I'm
Yes.
sorry about that, ma'am.
You're right.
So, but now
No
if you cut
problem,
it
I
from
understand.
before 0. I understand now. Thank you, ma'am. Thank you. I get it.
Yes, you have to cut it here at 1 because you know our cost function starts at 1, goes to 0, goes to -1, goes to 0, and goes to 1. So then this is part here is our cost function.
Thank you, ma'am.
So if you come and check now, you cut it here again, it starts from 0 here. If you're cutting it here, it starts from 0, starts from 1, goes to 0, -1, 0, and 1. Here, 1, 0, 0, and -1. Do you see how you check those depending on when you cut? So here they were just showing you how the extension of a sine function is.
Thank you, ma'am.
Okay. So now you see this is our question. We say that from 1 to 0, -1, 1, and that. This is what we drew using a unit circle. Do you look at the above and below? Do you see how they cut it? The above and below, it looked almost the same, but they cut it here and cut it here. Now there's our cost function. So meaning starts from 1, goes to 0, goes to -1, goes to 0, goes to 1. So there's our cost function. Are we all together, guys?
Yes, ma'am.
Yes,
Thank
ma'am.
you. These are the graphs of one period, one complete period. Somewhere they want the one complete period. Using the fact that these functions are periodic with the period 2 pi, we get their complete graphs by continuing the same pattern to the left and to the right. Do you see that? Now, what you were seeing in other notes and papers in grade 12 is that now they were combining one complete periods. So now they extended to the right and extended to the left. Are we all together now?
Yes, ma'am.
Mm.
Dango. The graph of sine function is symmetric with respect to the origin. We know that this is expected since sine is an odd function.
Wait, ma'am. Please go back to the previous
yes.
slide. Please go back to the previous slide.
Yes.
Where it is written 0 is greater than equals to t greater than equals to 2 pi, is that the domain?
That's what's this? That's the
Like under
domain.
what
Yes.
period?
Yes.
Okay, thank
That's
you.
the
I'll just make
domain.
sure.
Remember, yes, thank you. It's the domain because you used to x and y. So we are using t. Remember, our pi over 2, pi over 3, we're using t.
Yes, ma'am.
Thank you.
Thank you.
Since the cosine function is an even function, its graph is symmetric with respect to the y-axis. So let's graph the transformations of sine and cosine now. We now consider the graphs of a function that are transformation of the sine and cosine. Let's sing the song. Sine of x, let's draw it one last time. Cos of x, help me to sing it. Where do we start? With sine, where do we start?
0.
0.
Then
1.
Pi over
1.
2.
0, 1, then
Minus 1. I mean 0.
yes, then
Minus 1.
then
0.
that's a good choir. For x, where do we start? For cos, where do we start?
1.
1.
Then
0.
0.
okay, sorry, my pen. So we started 0, 1, then 0, then
-1.
then
-1.
0.
0.
And 0.
Then 0.
1.
we are good, Mus. Can we continue now?
Yes, ma'am.
Thank God. Then I'm happy. If you are there, then the cosec and the what is nothing. It's nothing.
Yes, it.
Yes, it's nothing. It's nothing. Sketch the graph of each function. Do you see that? So they say sketch the graph of a function. What do you think they did to f of x? What did you think they did to cos to get cos f of x?
They shifted it upwards by 2
By how many units? Danko. They shifted upward by 2 units. Sketch the graph of each function. Did you hear they say sketch the graph of each function? There's a question that says sketch the graph. somewhere, ne? I'm not going to point out. Or in the assignment, because you attended the class. There's a question that says sketch the graph in the assignment. Right? Did it put one complete period?
No.
It didn't. So if you do one complete period there, I'm coming to zipper you. I want you need to extend to the left, to the right. Are we all together? I'm giving you full marks here.
Yeah.
Are we all together? So that question, I'm not mentioning which one, because it didn't say sketch for one complete period. It wants you to sketch. So I want you to extend to the left and extend to the right.
But
a little
ma'am,
bit to
why,
the left. And
why don't you just like restrict us like normal?
I did restrict you.
No,
For the
like
first question I did. For the second one, somewhere, there are 2 questions of you sketching.
I mean,
One
Grace,
is restricted. Yes?
I mean, like, just do it the way we've been doing with sets and everything, not the way you are asking it.
It's because I want to
Please.
see. That's how they ask it even here.
Eish.
You see, when they say one complete period and you come with something along things, then you are wrong. One complete period is that one of start from 0 to 1 to 0 to -1 to 0, like that one. From 0 to 1 to 0 to -1 from 0, like that. That's one complete period. Now, if they say sketch, I want you to start 0, 0, and then again repeat 0, and then on the left-hand side as well. Let's do that. So here they didn't say one complete period, but we'll start with one complete period, isn't it? So we know that our cost function. So let me move this somewhere because it's taking my space now. It's taking my space. So I know that if I have y is equals to cos of x, right? Let me draw it here. Quick. I know that I'll say 0. I know that my period for this is 2 pi. So we start there. So we say period is equals to 2 pi. We say it ID, we call it ID. It means that it's the things the steps that we are dividing with. SD or ID, let's call it whatever. So we know that it's period over 4. So then that's 2 pi over 4. We know it's pi. The answer is what? Pi over 2. So then we start and say, okay, we start from 0. We add this 2 pi, the ID. We come and say this is pi over 2. Then from pi over 2, we add another ID, which is pi over 2. We get what? 2 pi over 2, which is pi. And then we add another 2 pi over 2 to this point. We get 3 pi over 2. We add another 2 pi from this point. And then we get 4 pi over what? Over 2, which is 2 pi, because the period is 2 pi. Are we all together at that point? Now, because we know cos starts from 1, right?
Yes.
Okay, let's do this. We know cos starts from 1, right? So we know cos starts from 1, comes to 0, goes to -1, goes to 0, and goes to 1. So this is your function graph. Are we all together? There.
Yes.
Now, because we know this is 2 pi, let me write 2 pi. And here they say sketch the graph. They didn't talk about one complete period. So what you're going to do is you will make sure that you add another period. And we know our period is 2. So you go to this point. Now, this is our new 0 there. This is our new 0. And since that is our new 0, you then say 2 pi plus 2 pi gives you 4 pi, which is 4 pi. So from 2 pi, remember 2 pi was what? Was 4 pi over 2. So you add again 2 pi to get what? 5 pi over 2. You add 2 pi to get 6 pi over 2. You add 2 pi to get 7 pi over 2. 7 pi over 2. And then you add another pi over pi until you get to this 4 pi. Are we all together? Then you start again. It's cos. It starts from 1, goes to 0, goes to -1, goes to 0, goes to 1. Then you have extended it to the right. Are we all together then, guys?
Yes, ma'am.
So then to extend it to the left, you know that if I have 0 here, if I have 0 here, to extend it to the left, it means the length there as well has to be what? Has to be 2 pi. So meaning that if you look at the length between this point here and that point, this is from here to here, it's 2 pi. The distance from here to here is 2 pi. So if you extend it to the other side, then it means that it will also be from 0 to here, -2 pi. And you know it's divided again as well. So here, you know, it starts from 1, goes to 0, goes to -1, goes to this point, and then goes to that point over there. So this will look like this. Are we all together? So this is y is equals to cos of x. Are we all together, yes or no? Or there's a hand?
Ma'am,
Guys?
can I ask?
Yes.
Ma'am, can I
Mhm.
ask, can you start from negative pi and then go to, what is it, positive 3 pi? Because it's 2 periods, right? Oh.
So from negative pi to positive what?
3.
Eh? Positive 3.
Yes, ma'am.
But if you start from negative pi, and then one complete period to positive 3, if you add them, do they give you 2 pi?
No.
Yes, ma'am. It's a 2 pi.
No, it will give you 4. It won't give you 2 pi.
Ma'am, we'll give you 4 pi and because like you said you must not make one period, must make more than one period. So give us 2 period.
Yes, but remember, I want you to always keep, what's this? I want you to, the reason why I'm doing that, I want you to always draw 1 period, 1 period, 1 period, 1 period. Do you see that?
Oh, okay.
That's what I want you to do. So let me just draw it faster. So normally we know that this thing is irritating. I'm sorry, can someone not talk for now, ne? So this is y equals to 2 plus cos of x. So let me just explain it very quickly from my side. So this will be, how do I remove this thing? I don't know why now there's a new feature of having this small thing like this. Okay, so then, as I said, we move with the interval of pi over 2 because you always start from 0. Remember, your cos function always starts from 0 to 2 pi. That's where I want you to start. So meaning you move by, remember we said ID, the step at which you move. Let's call it SD, the step at which you move. We said it's period over 4. In this case, our period is 2 pi over 4. So meaning the step will be pi over 4, pi over 2. So meaning that if you're going to move from here, you need to make sure that you end up at 2 pi. If you are going to extend, you need to add another period here. It gives you what? 4 pi. Are we together? If you are going to extend to the left here, it means that you are needing another, from 0, you're adding another what? Another period, which will be -2 pi. Do you see that? So when you are going to draw, you are going to keep on adding pi's. From -2 pi, let's start here. It's easy. From 0 to, if you add pi over 2, you get pi over 2. And then here you get 2 pi over 2. Here you get 3 pi over 2. And here you get 4 pi over 2. Let's write it here. You get 4 pi over 2. And we know 4 pi over 2 is the same as 2 pi. Then, because it's a cos function, this is 1. This is -1. Because it's a cost function, we know it starts from 1, 0, -1, 0, and 1. So that's the first period. Now, because they didn't say one complete period, meaning you can extend it. So it means that here we know it's 2 pi. If you add 2 pi plus again this pi over 2, you get what? 5 pi over 2. You add again another pi until you get to 4 pi, because the last point here is 4 pi here. It's 4 pi. So then you add pi over 2, you get 6 pi over 2. You add another pi over 2, you get 7 pi over 2. You add another pi over 2. Then you get to this point, which is called pi. So then we start again. We know cos starts from here, goes to 0, goes to -1, goes to 0, and comes to 1. So then you have extended it to there. And then you come this side. You know when you add, what's this? When you add pi over 2, normally me, I like taking these points here because they look the same. So when you add pi over 2 on this one, you'll get -5 pi over 2. And then on -5 pi over 2, add again pi over 2, you get 4 pi over 2. Remember, you have to get to 0, 4 pi over 2. Then you add another 4 pi over 2, you get 3 pi over 2. And then you add another, what's this? Pi over 2, you get 2 pi over 2, and then you get 0. So then it starts from 0, goes to 1, goes to, okay, something is wrong here. Something is wrong here. So if I add pi over 2 from 0, I get -pi over 2, -pi over 2, 2 pi over 2, then 3 pi over 2, then 4 pi over 2. So something like that. So then it means you start from 0, starts from 1, goes to 0, goes to -1, goes to 0, and then goes back to 1. Then you have extended it like this. Do you see that, guys? Hello?
Yes, ma'am.
Now, because they added 2 units, meaning that every point should be increased by what? By 2 units up. So 2 units, we know this point was 1, isn't it, guys? These points were 1. So these points become, when you add by 2, what do you get? 3, isn't it? So the point comes here. This point was at 0. If you add by 2, what do you get? It's somewhere at 2. This point was here, so this point will be here. This point was here, so this point will be here. This point was here, I'm sorry. Okay, so this point is this one over here. This one is this one over here. And this one, if you add, it's a -1. If you add by 2, you get what? -1 plus 2, guys, you get 1. This point to be here. Let me just write it so that I don't confuse it with the color. So this point comes here. This point comes at 2. This point comes at 1. This point comes at 2. This point comes at 3. This point comes at 1. This point, sorry, this, oh, I'm confusing myself here. Can I please help me? Okay, let's do point by point with the, which color? Blue. So we are moving 2 units up. Let's start with this point over here. It goes to 3, isn't it?
Yes.
Okay. The next point is what? It's 0.
2.
So it goes to 2. We are done with this. We are done with this. The next point will go to what? This point will go to what?
1.
Thank you. We add by 2. And this point will go to?
3.
It's at 0. Look at this. It's at 0. 2 units up.
2.
So it will go to? 2. And this point here
You
will
see,
go
ma'am,
to,
for us not to be confused, don't put the blue also on the original graph.
alrighty, let me fix it. Let me fix it, okay? We go back, we have the blue. So the first point, I will tick it. The first point goes where? This point here. It goes to +3. The second point goes to
2.
2. This point here goes to
1.
1. None.
Yes, it's 1 because it's at -1 plus 2 is 1. And then this point goes to
2,
and then this point goes to
3,
and then this point goes to
2,
this point goes to
1.
1,
and then this point goes to
3.
and then this point goes to
2.
this one
3.
3. And then this point goes to
2.
2. And then this point goes to
1.
1,
and then this point goes to
2.
and then this point goes to 3.
3.
Thank you very much. Thank one complete period. There's another complete period. There's another complete period. Let's go 2 plus cos of x. We're all together there.
Yes,
Yes,
Do
ma'am.
you see shift? Yes. So it shifted 2 units up. Okay. Let's do the next graph. The next graph, I think it says y equals to minus cos of x. What do you think
Ma'am,
they did?
ma'am, before you move, can I ask? Remember we said earlier, normally, well, in high school, we used to write it from -360 to 360.
Yes.
I want to know, like, in order for us, like, if you request a graph like that from us, how would you ask it if you would?
The first part, you consider the period.
Yes.
In high school,
Like,
they
would you
wrote it
say,
from -360. Sorry. Yes. Repeat.
would you like say maybe draw 2 periods or draw a period from the negative side and the positive side? Like, how would you ask a question like that?
I would just want you to extend one period to the right and one period to the left. That's it.
So you
Okay.
wouldn't put a limit on it. So you wouldn't tell us to limit
No.
from -pi to +pi.
No.
-4 pi. Okay.
Yes, I just want you to, you see what we did here. We extended an extra period to the left and an extra period to the right. So we have 3 periods. That's what we did. We have the first period, which is from here to here. This is 2 pi. From here to here, 2 pi. From here to here, 2 pi. So this is one complete period of cos, another complete period of cos, and another complete period of cos. If you draw like that, then I'm fine.
Then that means it doesn't matter if someone has 3 complete periods and someone have 4 complete periods, as long as we have the shifted part.
Yes, as long as you have some to the right and some to the left, then it's okay.
Also, I can have.
But you see, the thing is, if you, yes.
So I can have a period from positive to positive 2 pi to -2 pi. It's fine.
It's fine because if you have positive 2 pi to -2 pi, it means that you'll have only this two of these. Do you see that?
Yes.
Yes.
Yes, it means you have that, only that.
Thank you.
As long as if your distance between the periods is correct, because that will affect you when it comes to your exam. Then it means if you don't understand here, and then some of the markers, because remember, I've people who help me to mark. If they mark you right in the exam, you might get it wrong because then you didn't understand how to sketch it in a period. Are we together, guys?
Ma'am. Yes, ma'am.
Yes. Now, the second one is this. What is this? What transformation is this, guys?
It's reflection.
About what?
The x-axis.
Thank you. It's the reflection about the x-axis. Do you see that? So meaning that your y values changes. Your positive 1 becomes your negative 1, and your negative 1 becomes your positive 1. So let's start. This point becomes what? This point here. Konje, you said I shouldn't highlight. I will confuse you. Okay. Let me use a blue color again. This point becomes what? It's a reflection, isn't it? Becomes negative 1.
Negative 1.
And then this point becomes?
0 becomes 0.
Thank you. And this point becomes?
1.
Positive 1.
1.
Positive 1.
The 0 becomes 0. Positive 1 becomes? Negative 1. And then 0 becomes 0. Negative 1 becomes? Positive 1. 0 becomes 0, then positive 1 becomes negative 1, 0 becomes 0, negative 1 becomes positive, 0 becomes 0, and 1 becomes that. So then the graph looks like this. So it faces the other way. Do you see that, guys? So it faces the other way. The original was like the yellow one, like this. Are we all together there?
Yes, ma'am.
So let me go in and look at the notes. So here are the graphs. So here you see it's shifted up by 2 units. They're just showing you that shifted up by 2 units. And here they're showing you that the cos function becomes, you see the reflection about the y-axis. You guys were right. About the x-axis, sorry. You guys were right. Are we all together now on the cosine and the sine function, guys? On drawing it, isn't it?
Yes, ma'am.
Thank you. Let's graph y is equal to sine x. We start with a graph of y is equal to sine x, then we multiply all y values by each by point of 2. Do you understand that one, guys? Hello? You understand what they're saying? Okay, good. This has the effect of stretching the graph vertically by a factor of 2. To graph y is equal to half sine x, we start with a graph of y is equal to sine x and multiply the y coordinate of each point by half. This has the effect of shrinking the graph vertically by a factor of 2. So let me remove this small block over here. This is what you get. Basically, this. What you get. So they are saying that, let's remove this block again. So they're saying in general, for the function y is equal to a sine x and y is equal to a cos x, the number, absolute value, is called the amplitude. Meaning that the positive value of this is called the amplitude. And if I see you in the assignment, you say amplitude is equal to -5, I'll tip you, because an amplitude is a distance from here to here, from here to here, from here to here, from here to here. Basically, it's the height of the wave. So if it's the height, you never have a negative height. It's a positive distance. Are we all together there?
Yes, ma'am.
Thank you. Now they say find the amplitude of y is equal to -3x and sketch its graph. What is the amplitude?
minus 3.
Negative 3.
3.
I'll zipper you.
I
said the amplitude is the distance. So the amplitude is equals to
This
3. So the amplitude, this is what you write, is equals to absolute value of negative 3, which is equals to 3, because it's the distance. Do you see that? So now I'll only draw one complete period, because now you know how to extend to the left, to the right, isn't it, guys? So we know that this is a cos function, so meaning that the cos function was 0. Now it means here the distance will be 3. It won't be 1 anymore. Do you see that? It will be 3. So then it will start from, so we know this is, because we know that the period of this is 2 pi. So I have to end at 2 pi. And you take the period, divide by, to find the SM, the interval that we divide, the step that we divide with. So we then say period, again, I'm repeating it, over 4, which is 2 pi over 4, which is in our case pi over 4. We say this is pi over 2, 2 pi over 2, 3 pi over 2, and pi over 2. Let's write it here. Pi over 2. So meaning that this graph, look at how I'm drawing this graph. I know my cos starts from 0. It goes to, it starts from 1, goes to 0. 0 goes to negative 1, goes to 0, and then goes to 1. It's like this. Do you see that? So here, again, I have 2 pi. So I want to go this side and add, as we added here, I have 4 pi. So meaning that here it's 5, so this is 6 pi over 3 plus 7 pi over 2. Why am I saying over 3? Okay, something is wrong here. So this is the same as 4 pi over, what is pi over 2? 2 pi plus pi over 2. So this is 5 pi over 2, 6 pi over 2, 7 pi over 2, and 8 pi over 2. So I'm extending. So it starts from here, comes here, then goes there, and goes to 1. So I'm extended to this side as well. Right?
So,
and let's assume we extended there. Now, this is y is equals to cos of x. What I have drawn, 3 cos of x. Do you see that, guys?
Yes, ma'am.
Now, for negative, it means we have reflected the graph. Don't forget that. We have reflected the graph. I want the pen. Where's... So it means we have reflected the graph about the y-axis. Yeah, this thing today is irritating me. So we have, because there's a negative here, meaning that we have drawn the graph y is equals to 3 cos of x. So now, because there's a negative, we are reflecting the graph, meaning that this part becomes this part. This is 0. This is 0. I mean, this one becomes this part. So your graph will start like this. Like this, then goes up, then goes down, then goes up, then goes down, like this. Are we all together? So this is your graph. Are we all together on how I drew that graph, guys?
yes, ma'am.
Okay.
So, ma'am, in the assignment,
Yes.
if I just draw the positive side of the graph, but it is also still 1 period, will you mark me right?
I don't want one complete period. I want you to draw the positive and the negative, preferably. If they didn't say one complete period. Do you see that?
Okay.
Yes. So here, so they say the amplitude is positive. So the largest value of the graph is 3 and the smallest value is negative 3. All right, so to sketch the graph, we begin with cos. Remember, they said we begin with the initial cos. Then we stretch the graph vertically by 3 units. So we get y is equal to 3 cos x. And then we reflect it about the x-axis, which is the red one that we got. the same way we drew that. Are we all together there? Am I losing someone, guys? Hello? Should I think silence means yes, we are sorted?
Yes.
Danko. So now they say since the sine and the cos function have a period of 2 pi, so now we have been looking at y is equals to a number here, cos of x. Now they say, what about a y is equals to a number and cos of kx? So what is the new period here? Right? So they are saying that now the period changes. If you have a value of k here, the period changes. Because remember, initially this is what you had. This chart. So initially, this is what you had. So you had y is equals to sine of x. Now and then there's a here. So the a value, the amplitude doesn't affect the period. Let's get it correct. The amplitude doesn't affect the period. Do you hear that, guys? It
Yes,
only
ma'am.
affects the height of
Yes,
the graph. But now the k will affect the period. K.
Yes.
So meaning that initially we know the period of this one is what? Is between 0 and
2 pi.
so it's between, yes, x is between 0 and 2 pi, isn't it? Now we remove x and put k plus x, so meaning that x will be between what? 2 pi.
over k.
So if we divide by k, divide by k, divide by k, so meaning that now our new x for this graph will be what? Between 0 and 2 pi over k. Are we all together? That's the new period. I didn't lose anyone, guys.
Yes, ma'am.
So meaning that for both cos and sine, this is the new period. For sine of kx and cos of kx, this is the new period, which is 2 pi over k. So let's go to our notes then. So then they are saying, okay, fine. Since the sine and the cosine function have period of 2 pi, the functions y is equals to kx and y equals to a cos kx. K should be positive. For a complete period, complete one period has k varies between 0 and 2. That is, it means that the period will be, this will be the new domain. So these functions have one complete period as x varies between 0 and 2. So therefore, the period will now be 2 pi over k. So the graph of these functions are called sine curves and cosine curves, respectively, right? Collectively, sine and cosine curves are often referred to as sinusoidal curves. So here we go. They say that if you have a function of sine and cosine, if you have a sine and cosine curve, and it has a k here, and it has an a here, this a here is called the amplitude, right? And this k here is then now will be used to find the period. So meaning the new period is what? Is 2 pi over k. If k was equals to 1, you know, just you'll have cos of x. But if k is equals to 2, like this one, so the period of this function will now be, what? Will now be 2 pi over 2, which is then the new period is 2, is pi, sorry. Are you all together, yes or no?
Yes.
Hi, ma'am. Can you please repeat that? I'm a bit lost.
Okay. Remember, we said that the function y is equals to cos of x, right? What is the period for that?
2 pi.
2 pi. Why? Because k was 1. The number next to x was 1. Do you see that?
Got you.
So 2 pi divided by 1 is equals to 2 pi. Now, if the number is no longer 1, it's another value, let's say 2, cos of 3, for example, 3k. So meaning that the new period for this function here will be 2 pi divided by the number next to x, which is 3. So this is the new period for this function over here.
Okay, so we're looking at the number before the variable. Got you. Okay, thank you.
Yes. So we then say number before variable, 2 pi divided by k. We know for 10, it'll be number before the variable. So 10 is pi, so then it'll be pi divided by k. Thank you.
Thank you, Mama.
So now since, you're welcome, since the period is 2 pi over 2, then y is equal to this. So look at this, what they're saying here. Let me just explain it by drawing it fast, very quickly. The section is a bit long, guys. So let's do this. Whoa. Okay. Let me draw it so that you see it. So they are saying, okay, we have y is equals to sine of x, right? So we know that sine of x, we know the period is equals to 2 pi. What is the number before x there? What is the number before x? It's 1, isn't it? So 2 pi over k, which is 1. So meaning the period is 2 pi. And we say the step at which we divide, SM or SD, we say period over 4. We then say 2 pi over 4, which we then get pi over 2. That's what we have been doing. Do you remember that, guys? Or am I the only one remembering it?
Remember.
So then when we go and draw this function here, this is what happens. Do you see that? The amplitude doesn't affect, it doesn't matter. It only affects this values here. This is -1 and this is 1. I mean, this is +1 and this is -1, y and t. So then we say, okay, fine. When I draw sine, I have to move from 0 to 2 pi to this period. Is this pi over here? The reason why I'm repeating this is because it's important for your sec and cosec and whatsoever. So then I know sine starts from 0 to 1, to 0 to negative. Oh, what have I done? So it starts from 0, then 0 to 1 to 0 to -1 to 0. So that's my sine function over here. Now, if I have a 2, now y is equals to sine of 2x. I know my sine has a period of what? Has a period of 2 pi. So then the new period for this one will be period is equals to 2 pi. What is the number next to the variable? Is 2. So then that will be 2. Are we all together there? So 2 divided by 2 is equals to pi. So the new period for this function will be pi. So how do I draw one complete period? Meaning that it will be from 0 to what? To pi now. Are we all together, guys?
Yes, ma'am.
So meaning that now the S, we call it the step for division. SD will be period. What is the new period? It's pi, isn't it? So it's pi divided by 4. So meaning the new steps we're going to move on is pi over 4. So I start from 0. I add pi over 4. I get pi over 4. At pi over 4, I add another pi over 4. I get 2 pi over 4. At pi over 4, I add another pi over 4. I get 3 pi over 4. And then at this pi over 4, 3 pi over 4, I add another pi over 4, which is what? I get pi, which is this one. So meaning that we know that sine starts from 0, goes to 1, goes to 0, goes to -1, goes to 0. So that's my new sine function. Do you see the difference? How the k affects? Hello? Are we all together there, guys?
Yes, ma'am.
Alrighty. So then you can, yes?
Irrespective of the k value, our SD will be pi divided by 4. It will be a step.
Please repeat.
Irrespective of the k value. So
Yes.
the k value doesn't change our step, which will be pi over 4.
Our step is always period over 4.
But then
So the k value also affects our steps.
Oh, okay.
Yes.
But then
The
without
k,
the key value,
you saying what?
Without the key value, it will be pi. Our step will be pi divided by 2.
Yes, because what will be the period without the k value? What will be the what is the period without the k value of sine? The period, isn't it? It's 2 pi. So then divide by 4 will be what? Pi over 2.
Oh, I see.
Yes. Yeah, today Teams is doing some few things. Is it Microsoft or what? It's doing things that I don't understand. Things are just popping out.
Excuse me, ma'am. Before our SD, ma'am was using ID. What do you call? Can you just...
Okay, let's call it SD, step for division, like steps that we use. Let's just call it SD. I see I'm confusing.
Man.
Interval, yes. Interval for division. Let's put it a name. Interval for division. So should we call it what? ID.
What did the I stand for?
ID.
Or interval.
Yeah, let's say,
Okay.
yeah, interval. So interval for division, it's the one that you use to add so that you divide the intervals in that period to 4. So let's call it 1 ID then, not SD. Let's remove SD, let's call it ID. So now there's one thing. Remember, you know what a complete period is of a cost function, isn't it? And you know what a complete period for a sine function, isn't it? You don't just draw. Because someone said, ma'am, what if I start from negative infinity to positive infinity? Yes, of course, you'll draw it for the rest of your life. But there's an appropriate interval on which you have to start a one complete period. Do you see that? Do you hear the restriction, good people?
Yes, that's what I was asking.
Yes, we call it an appropriate interval. Let's call it what do we call it? Should we call it AP? An appropriate interval. Unless you write an appropriate interval is equals to. Let's shorten it. Let's call it AP. An appropriate interval. So the appropriate interval for one complete period will always start from 0 to 2 pi over k. That's your restriction. Are we all together now?
Yes, ma'am.
Thank you. So this is what we drew. So they say since the period is 2 pi over 2, which is equals to pi. The reason why it's 2 pi over 2 because of this 2, right? So graph of one complete period, meaning that with y is equals to sine of 2x, ne? You go and find the amplitude. That's what you're going to do in your assignment. Amplitude when you're sketching. Your amplitude will be what in this? In this case, your amplitude is 1. So you then say amplitude is 1. And then you say period. And then your period is what? Your period is 2 pi over k. In this case is 2. So this is equals to what? This is equals to pi. And then you go and say an appropriate interval for one complete period, AP. But you go and write it because my markers don't know that in class we said it's an AP. So you go appropriate interval on which you complete is equals to. Then you write it's 0 and 2 pi over k. So in this case, it will be 0 and pi. Do you see that? That's where you start. That's how we started when we drew. We said 0 and pi. So that's where our sine function started. Then you can extend it from there and extend it to that side there. Are we all together now, guys?
Yes.
Yes, ma'am.
Good. Okay, so here they're just showing you that if k is less than 0, less than 1, and k is greater than 1, it's shrinking and stretching the graph. We did transformation in the previous in chapter 2. So find the amplitude and the period of each function and sketch them. Can we just do one complete period, guys, and then you'll extend to the left, to the right, so that we become quickly? Yeah?
Yes, it's fine.
Thank you. So now let's do for the first one, A. We know that A, what is our amplitude? They want our amplitude.
4.
What is our amplitude? Is equals to?
4.
2, 4, ma'am.
Thank you.
Yeah.
And then they want our period. What is our period?
2 pi over 3.
2 pi over k, which is equals to 2 pi over 3. Do you see that? That's the new period. And then what else do we have to find here?
Interval.
We found our amplitude, we found our period. What else do we have to find, guys?
Interval.
Which one first?
Period over 4.
The interval for division, the one, yes. We call it ID, isn't it?
Yes.
We call it ID. So
Yes.
interval for division will be period over 4. So our period over 4, this is what? 2 divided by 4. What's the answer there?
8 pi over 3.
It's pi over what, guys?
Ma'am, don't we divide 2 pi by 3 first before we divide
Pi
it by
over
4?
6. Right? After pi over 6. Did I do it wrong, guys? Help me.
No, you did it right. The first thing
Hello.
you do and get to. Oh, copy.
You're getting
Ma'am,
pi over 6, right?
Yes, ma'am.
Why do I feel like there's some form of confusion here? What is the confusion?
It's the trying the
Okay.
functions
Now that
without
we're
calculating.
done with amplitude, period, and interval for division, don't do the functions without calculating. You have to calculate, guys, because then it'll be wrong. We just draw our graph anyway where we want or where we feel like, or depending on our mood. No, we got this one here. 2 pi over 3. That's where we start for one complete period. So then this, meaning that equals to, let's start from 0. So it starts from 0 to 2 pi over 3. So that's 2 pi over 3. Which steps are we using? We're using pi over 6. So 0 plus pi over 6, that's pi over 6. Pi over 6, then pi over plus pi over 6, that's 3 pi over 6, plus pi over 6, that's 4 pi over 6. And 4 pi over 6 is 2 pi over 6, isn't it? So then that's our graph. So because it's a cos function, we know it's at 0, it starts from, the amplitude is 4. So here it will be 4, and here will be -4. So it starts from 4, goes to 0, goes to -4, goes to 0, and goes to 4. So your graph will look like this. Do you see that, guys? Did I lose anyone? Hello?
No, ma'am, we are following. It's just that the network, like your
On
speech
my
is
side.
delayed.
Oh, okay. Let me try to fix it. I don't know what's going. Okay, let me try to fix it. Let me hotspot. Let's see. Am I better now? Hello, can you hear me, guys?
Yes.
All right.
Yes, ma'am.
So meaning that now, for the next period, if this is, guys, tell me, if this is 2 pi over 3, this here, 2 pi over 3, for me to draw a next period, where should I end? I just want to see if you understand. Where should I end? At
4 pi.
4 pi over 6.
Fractions.
Or 4
I
pi
don't
over
know.
3.
you have to add this one, 2 pi over 3, add another 2 pi over 3, which is, well done, 4 pi over 3. Then you can start dividing this. How do you divide this? You add by 2 pi over 6 from this point here to this point there. Are we all together?
Yes, ma'am.
Yes, ma'am.
Thank you. So now, the above one, the same thing. You start with the amplitude. What is the amplitude? For B. The amplitude is positive 2.
It's
And then,
2.
what is the period?
It's 4 pi.
Thank you, which is 2 pi over half, which is equals to 4 pi. Well done. And then what is the interval for division? It's
Isn't it
period.
pi? Isn't it pi only?
Well done, which is 4 pi over 4. It means you guys know. And then what is the appropriate interval at which you have to start? You cannot start based on how you feel. So it will be between what and what?
0
to
to
Guys?
4 pi.
That's
Thank you.
positive 8 pi.
Then you start drawing. Are we all together? I didn't lose anyone, isn't it?
Yes.
Yes, ma'am.
Thank you. So you don't just draw because you feel. You start somewhere. So then they say we get the amplitude and the period from the graph of the function as follows. So the amplitude is 4. The period now is 2 pi over k, which is 2 pi over 3. Well done. So then the amplitude is 4 and the period is 2 pi. So the graph is that. Do you see what we did? We started from 0 and we did one complete period. And you were right. You added this, another complete period. So this is 2 and they extended to the left as well. Here we said the amplitude is 2, the period is 2 pi over, well done, and then the graph is this. But you then did the appropriate interval. Okay. Are we all together, guys? I'm moving to the next one. Sure, this is a very long section.
Yes,
I'm
ma'am.
moving to the next one. So remember we had y is equals to a sine of x, kx. This is what we had, isn't it, recently? And then we said the period is equals to 2 pi over k. Now, what if we have a shifted graph to the left or to the right? So meaning we have now k is equals to x minus b. What do you think the period will be?
Two pi minus a plus b.
2 pi plus b.
Yes, ma'am.
Yes, ma'am.
Okay, there's something missing there.
2
0 b is going to be b to 2 pi plus b. Yeah.
Something is missing.
Like, are we supposed to say 2 pi plus b divided by k divided by 4?
Let's wait. Now, we said the appropriate period for this one. Let's start here. What is the appropriate period for this one? To start where you have to start your graph. What was the AP appropriate interval for which you start the graph? AP. We said it's 0 to 2k. We said it's 2 pi over k, right? Guys, am I missing someone? Look,
No.
this is one complete period, appropriate interval for one complete period. So meaning that the appropriate interval for this complete period should also be different because now it's no longer the same. Do you see that? Because we said y is equals to sine of x, the appropriate interval where you need to start is 2 pi. Now we say y is equals to sine, hey, what have I done? Okay, guys, charge. There we go. So we said if we have y is equals to sine of x, we don't just start anyway. We have an appropriate interval for which you start your one complete period. It's from 0 to 2 pi. So then you can extend to the left, to the right. Then if you have y is equals to sine of kx, right? Then your appropriate interval where you start your function, it will be between 0 and 2 pi k. Now there's a shifting here. Where do you start? So y is equals to kx minus b. That's where we need to start. Where is your appropriate interval for which you start your one complete period? That's where you need to start.
So it's gonna be 0 to b.
Not really 0 to b, but it will be from 0 to. Remember how we found this one? We said initially we had from 0 to x was from 0 to 2 pi. Then we replaced with kx. So now it's between 0 to divided by k, divided by k, divided by k. Yes, so this was x between 2 pi over k. So now this one, we have k x minus b between 0 and 1 again, pi. So then it will be over k over k over k. So this means that it will be between 0 x minus b 2 pi over k. So the appropriate interval will actually be between b and what? 2 pi over k plus b. So the new appropriate interval will be b 2 pi over k plus b. So that's the new appropriate interval. Do you see that? The reason why I'm deriving it is because so that you understand it. It's not in the formula sheet in the exam. There's no formula sheet. Are we all together there?
Ma'am, can you come with our own formula sheet in the exams?
No, you can't come with a formula sheet. Then you are copying. It's not open book.
Okay.
The formula sheet have to be in your mind. So now they are saying that shifted sine and cosine, if you have a function like this and like this, where k is positive, the amplitude still remains the same. The period is only affected by k, and the horizontal shift affects the appropriate interval for which you graph one complete period. So this is what we got. Do we see that, guys? Yes or no? Sure. Find the amplitude, the period, and the horizontal shift of y is equals to 3 sine 2x minus this and graph one complete period. Can I just do this very quickly, but I need 2 seconds to drink some water. Are we all okay? You can discuss
Yes,
it, but
ma'am.
I need 2 seconds, yes.
Hi guys, why do you always do this?
Khuluma usize. Eh,
I don't know, we just follow the steps. Find the amplitude,
is 3.
find your period, find your
How
interval.
will you calculate your period?
Pardon?
You can,
Period ya o tlo calculate jwang?
2 pi over
Period is
k.
always
and then we're
2
going to
pi
write that
over
formula
k.
that we put down.
Excuse?
And you're going to write that formula that mem wrote down, which is 0, and then you're going to write what's in the bracket. Yeah, what's in the bracket. Wait, excuse me. It's a mistake.
2 pi over k. That's how you find your period.
But
period.
because in a x minus pi over 4. Suzenza njani?
Listen, our period for sine is always 2 pi.
Over
Ne?
4 years.
No, it's always 2 pi.
Mm-hmm.
Ne? But in this case, we are given the value of k, which is 2. So your period is going to be 2 pi over k.
Okay.
And then your interval. Normally, how I find my interval, I just take the thing that's in the bracket and equate it to 0, then solve for x.
Goku, your interval is going to be pi over 4. Your ID.
But remember, use the formula. Interval is your period over 4. So whatever period you're going to find when you write the 2 pi over 2, what's 2 pi over 2 is pi. So it's going to be pi over 4, yes, basically. But the easiest way, just take the things that are in brackets and equate it to 0, that's your interval.
Then what's your AP? AP yellow again? Because I think I'm confused. Got AP.
It's 3, Kapuyo.
Hmm?
3. It's 3.
Not
Okay,
amplitude. AP.
guys,
AP is the coordinates again.
the AP is the interval where you start drawing, appropriate interval. You can't just draw. Do you understand?
Yes.
Yes.
So you can't just wake up and decide, me, I'll draw from negative infinity to positive or from pi over. It's called a where you start. Like, for example, if you are running a race, you can't start at the finish line, guys.
You start from 0.
Yes.
Always.
Not always. You need to be very careful.
Okay, in this case.
In this case, you're not going to start from 0 because the graph has been shifted.
Oh, yes. It's
Do
been
you see
shifted
that?
by pi over minus pi.
Well
to
done.
the right.
Well
So your
done.
appropriate
So
interval is going to be 0 to pi over 4.
Not 0, not 0.
Minus pi over 4.
Your appropriate interval will be this one. You see that? Look at the 3 things. They are different. Let's look at the 3 things. They're different. Okay, the first one is the one we know. The first one will have this one. Initially, we had y is equals to, remember, when we have y is equals to cos of x, k is equals to 1, isn't it?
Yes.
So the appropriate, where you start drawing, the appropriate interval for one complete period will be between 0 and 2 pi over 1, which is equals to 0 and 2 pi. Do you see that?
Yes.
Now, if there's a k here, your appropriate interval where you start the first complete period, meaning it's this up, down, or this parabola look like function. We know this is sine of x, this is cos. Where you start drawing before you extend to the left or to the right, you start here if you have a k. And if your graph looks like this, Does it make sense?
Yes.
Now your graph has been shifted, so you can't start like 0. So you have to start. If it looks like this, now your graph has been shifted. Do you see that your graph looks like this? So then your appropriate interval will be what? B plus B plus the period.
So
Does
it's
it
going
make
to
sense
be
now?
pi over k plus pi over 4.
So your appropriate interval, what is B? Let's go. You see, they say B minus X minus. So you have to have a minus here. There's a minus. So your B is what? Is pi over 4. Do you see that?
Yes.
So since your B is pi over 4, your appropriate interval will be pi over 4, which is B, right? And what? Pi over 4 plus your period, which is 2 pi over K. What is K? Your K is what? Is 2. 2. So your appropriate yes. So your appropriate interval will be pi over 4 and 5 pi over 4. This is where you need to start your graph. Does it make sense, guys?
Okay.
Okay.
And why did
So
you say 5 pi over 4?
it's because I added pi over 4 plus 2 pi over 4. What is the answer? It's 5 pi over 4.
No, but I'm thinking 2 pi over 2 is 1. So it's going to be pi over 4 plus pi.
Yes, which is 5 pi over 4.
Oh,
Guys, your brains need to start working. You're not using calculators.
Are we not cross multiplying?
Cross multiply still. You get 5, no, not cross multiplying, but you still get 5 pi over 4. You guys are, hey. Okay, so now this is one completed. So this looks similar to what you have in the assignment, isn't it?
yes.
So let's look at it. So the amplitude, I want us to do it carefully. The amplitude is equals to what?
3.
3, thank you. Positive 3. The period is equals to what?
2 pi over
2 pi over 2.
2.
Which means the period is pi. Do you see that?
Divided by 4.
Now, the horizontal shift. What is the horizontal shift?
Pi over 4.
Well done. It's equals to pi over 4. Is this shift to the left or shift to the right?
To the right.
Thank you. So this is a shift of pi over 4 units to the right. Do you see that?
Yes.
Now, when we start to draw, we want, please mute, sorry, please mute. Someone, who's that, guys? So when we want to draw, we cannot just draw anywhere we like or where we feel like drawing. We have to have an appropriate interval to draw one complete period and stretch from there. Right? That appropriate interval. In your assignment, please write the whole word. An appropriate interval on which to draw one complete period is. This is what I want you to write in the thingy, right? Guys, are we together? So here we say we'll call it the appropriate interval. So the appropriate interval is B, and we know this is B, right? B plus 2 pi over K, which is our period. So we know B is pi, so it's pi over 4. B pi over 4 plus our pi, which is what we got here. So this is equals to pi over 4, 5 pi over 4. Are we all together? Yes or no? Am I losing people?
We are all together.
Yes. Now, you have this appropriate interval. You know my graph has to be between my first graph. In this is the sine graph. So we know a sine graph starts from 0, goes to 1, 0. It looks like this. We know the sine. For me to draw this thing, I'll draw it here. But I have to divide by 4. I have to divide this interval by 4. That's what we said. We'll call it an ID. So how do we divide this interval by 4? I go and take my period, divide by 4. This is what I want to see in the assignment. So my period is pi. So it's pi over 4. So meaning that I will start at pi over 4. I'll end at 5 pi over 4. How am I going to move? By the steps of pi over 4. So meaning that this is how it's going to look. One complete period. Right? So here we know it's 0. What is the amplitude? It's 3. So 3 here and -3 here. But do I start at 0? Do I start at 0, guys?
No.
Eh? No, I start at my AP, my appropriate interval from which I complete one period. So I know my pi over 4 is here. And I have to end at 5 pi over 4 for one complete period. How do I move? I move with this ID. So I know 4 pi over 4 plus pi over 4 is what? 2 pi over 4. Plus another pi over 4, it's 3 pi over 4. Plus another pi over 4, it's 4 pi over 4. Plus another pi over 4, it's 5 pi over 4. Do you see that? This one
Ma'am,
I
what about
use
the
to
2?
move the steps. Yeah?
What about the 2?
Which
Don't
2?
you? And it's 3 sine 2. Don't you expand before we do this?
The 2, we already done the 2.
Oh, excuse.
The 2, remember, affects the period. Here's the 2 here.
Oh,
This is the 2. Do you see that?
Yes,
The
ma'am.
3 affects the height. Here's the 3 here.
Ooh.
Do you see that?
Yes, ma'am.
The shifting affects the appropriate interval, which is B. Here's the B, and here's the B, which affects this.
Oh,
Yes. So and then the ID helps you to divide this interval, the appropriate interval, into 4. That's what the ID is helping you to do. It says, yes, I know that I have to write between 0 and 4, but do I just put points? No, you use the ID. How do you find the ID? You say period over 4, and we know our period is pi. And then you say, okay, I have to start from this lower bound and end at this upper bound, but I move with pi over the units of pi over 4 steps. Then you go and say, okay, it's a sine function. So then I know sine starts from 0. At this point, it goes to 3, goes to 0. Oh, sorry. Goes to 0, then, goes to 1, then 3, then goes to 0, goes to -3, then goes to 0. Like that. Do you see that according to the statement, we are right. The sine function has been shifted pi units to the right. Are we all together now? So I think you can go and write our assignment properly. Okay, I'm not losing. And is there someone who's having a problem here, or should I move on? We need to finish this section, guys. Hello, should I move on?
Yes, ma'am.
Yes, ma'am, you can move on.
Thank you. So there we go. We have the amplitude, we have the period, and the horizontal shift is also called the phase shift. Horizontal shift is called the phase shift, right? Pi over 4 to the right, well done. And since the horizontal shift is pi over 4, the period is pi. One complete period occurs, the appropriate interval. You don't just wake up and draw. You want an appropriate interval where you start, which is what we had there. And that's where you see, so we shifted. It has been phase shift by 4 units to the right. And the amplitude is 3. From here to here, it's 3. From here to here, it's 3. And then the distance from where your graph starts, here, to where your graph ends, it should be pi. Should I give you this one to draw, guys? Or you want me to explain it? Hello?
Can do it.
We can do it.
Yes.
You guys are making me a slave.
No, I'm saying we will do it.
So let's answer all together and then Memo will tell us where we're wrong. Because it's gonna take time.
Yeah, I thought you'd go and do it at night.
Oh,
We
okay,
can hear you.
She's saying that if she does it, rather let's do it because it will take time. Okay, let's just do it together then because it's similar to what we have in the assignments and the exam. Where do we start? Amplitude. Give me amplitude. Fast. Amplitude.
3/4.
Positive 3/4. Thank you. Period.
2
2 pi over 2.
2 pi divided by 4. Oh, dude.
There's so many answers. Please help. Period.
Pi. 2 pi over 2.
2 pi over 2.
2 pi.
Is someone confused there?
No.
Guys? Is there someone confused? Because someone is saying period is 2 pi.
Oh, ma'am, I meant 2 pi and then, okay, yeah.
Is someone confused why it's going on here?
No.
I
Look at
think
this.
you know, ma'am.
Look at this. Look at how this is drawn, guys. Do you see the x inside? There's only x here. Do you see that?
Yes.
And there's a negative here. Do you see that?
Yes.
I want to see that.
Yes.
Now, you guys are giving me answers, but there's a positive here and there's a 2 here. What am I supposed to do with this? Because mine is written as y is equals to a cos of k x minus b. So meaning that, let's go and write this in terms like this. So meaning that this will be y is equals to, my a is 3/4. We agree, right? Cos
Yes.
of
2.
2. Take out 2. Thank you. Take out 2, then you remain with x minus, plus.
1/3.
When you take
Pi over 3.
pi over, well done, pi over 3. But because it's a negative here, let's make it a negative. So this will be 3/4 cos of 2x minus pi over 3. So this looks like this.
Why can't the k be negative, ma'am?
Yeah, because k is positive number.
Okay.
It can never be a negative number.
Okay. Thank you.
Yes.
If you put it, no, it can never be you.
That you have, no. No, because normally in other functions, it's easier. Then it means that, no. It means you have reflected about the other what x's, but k will be positive.
Okay.
And in this case, k, for trigonometric function, k has to be specifically positive. That's what they are saying.
Okay.
Yes, because there's, no.
I think the only thing that can be negative is your amplitude value or your shift.
But your
Never
amplitude
k.
value has to always be positive because it's a distance. It's a height of a
Yes.
wave. Yes. So now, do you see now it looks clear now that our k is 2. So this is 2. And then what is our phase shift or horizontal shift or phase shift?
Negative pi over 3.
Thank you. Thank you. Well done. We know this is our b, isn't it? So this is our negative pi over 3. So what shift is this? This is shift
To the left.
pi over 3 units to the left.
Yes.
To the left. Yeah, you guys are going to get total in this assignment and this part of the exam. So what can I draw anyway on how I feel?
No.
So I have to find what?
The appropriate.
Appropriate interval.
Yes. The appropriate, we called it AP, but in your assignment, write appropriate interval for which to complete one period is equals to what? Remind me the formula. It's what?
B,
B,
Yes.
comma
comma,
B,
2 pi
Plus?
over.
Okay. So in this case, our B is what?
Pi over 3.
Our B is what?
the negative pi over 3.
Well done. There we go. Because it's shifted to the left. So you have to shift from 0 to the left of it. So it's negative. That's why I said to you, it should always look like this. Negative B, so that you know whether B is greater than 0 or B is less than 0. And here there's a negative, which is this negative over here, and this B is negative. Are we all together?
Ma'am, you said on the assignment we must write appropriate
interval.
Yes, you write appropriate interval for which you draw one complete period, the way they wrote here in the notes here. Right?
interval.
Is, yes. So that's how you're going to write it. And then after that, for both, even if they didn't say sketch one complete period, both, after that, then you extend. Remember that the other one, you first have to draw one appropriate interval, then you extend to the left and extend to the right. But here they said one complete period, so that's why we are drawing only one complete period for this one. But AP has to always be there. So it shows your learners that you don't just draw a graph. You start, learners or cousins or whoever you'll be explaining, you start at this point and then you continue drawing the graph to the left or to the right. You extend it to the left or to the right.
Ma'am,
And
yes, are the coordinates of the appropriate interval negative pi over 3 is to 2 pi over 3?
Not coordinates, they are bounds. They are lower bound. It's an interval, yes, lower bound and upper bound. So it's negative pi over 3 to negative 2 pi.
Not
Wait.
2 pi over 3.
Thank you. Positive 2 pi over 3. You didn't use a calculator, right?
No.
Thank you. You're right. So now, what is missing? I have this interval. I can put my graph. Do I just put my graph or I have to divide this appropriate interval? I have to divide it. So how do I divide it? I then call my ID. We called it ID. We said we are dividing. So our ID is period over 4. What is our period is pi. So even here we move by pi over 4. Do you see that? So meaning that we have to move, we start from here, we end here by moving by pi over 4. So then let's do the graph. Okay, I need some space. So our ID is equals to pi over 4. So then let's draw that. So we know our amplitude is what? Is 3 over 4. Here it will be negative 3 over 4. Now we have to start at negative pi over 3. And we have to end at 2 pi over 3. But we have to add what? We have to add pi over 4. Do you see that? So let's add. Negative pi over 3 plus pi over 4. What do we get? Why am I getting a guys?
Yeah. Minus 3 plus 12.
Huh?
Pi over
9 over 3. 9 pi over 3. Let me write
9
it
pi
down.
over 3.
Let me write it down. Wait.
Isn't it negative pi over 12?
Negative pi over 12.
I
Let me
cross
see.
multiplied.
Actually, it's negative 3 over negative pi over 3, ne? Plus
Pi over 4.
Plus pi over 4.
Isn't
pi
it
over 4.
negative pi over 12?
Well done. Negative pi over 12.
Multiply.
Hey, your brain is moving. You're even surprised.
Ah, don't use a calculator.
All right. I'm
She's
so
not
proud.
using it. She's not using a calculator. Her brain is moving now. It's approaching AI. Okay, and then now add pi over 4 again.
Yeah, Bo.
Add pi over 4. What do you get?
8 pi over 48. 8 pi over 48.
See?
Are you getting 8 pi? Remember, we are moving with pi over 4. So from
Hey.
here, the next pi is what?
8 pi over 4. I need to simplify. Desimplify, John. I need to simplify.
Is it 8 pi over 4?
It's 8 pi over 48.
8 pi over 48.
Hey, I made desimplify. I don't know how to simplify. Oh.
Okay, wait. Let me show you something. So here I said negative pi over 3. So this is times 4 over 4 plus pi over 4 times 3 over 3. So this is negative 4 pi over 12. Then plus 4 pi over, 3 pi over 12. So that's what we got. Negative
pi over
pi
3.
over negative pi over 12. Okay. So then we go and say negative pi over 12. So then we say negative pi over 12 plus again 4 pi over 4. Because you know that pi over 4, you can multiply to make the denominator 12, you can multiply by 3 over 3. So this is the same as negative 4 pi over 12,
6.
which is 3 pi over 12. So this is 2 pi over 12. Do you see that? So that's 2 pi over 12. 2 pi over 12 is the same as pi over 6. Do you see that? So this is how it's 2 pi over 12, meaning we are on the other side. Okay, so let's write it here, which is 2 pi over 12. Leave it at 12 so that you cannot be confused. 2 pi over 12. And then 2 pi over 12 plus again pi over 4. What do you get? 7 pi. No, not 7. It's 5 pi over 12. So then it's 5 pi over 12. Right? Then 5 pi over 12 plus another pi over 4 is what? Is 8 pi over 12. And 8 pi over 12 is the same as what? 8 pi over 12 is
2
the
over
same
3.
as?
2 over 3.
Thank you. 2 over 3. Okay, let me say this negative pi over is here. Do you see that? So we know this is a cost function. A cost function starts from what? From 1, isn't it? From up, ne? And then it goes to 0. Goes to this point. Oh, where is it? Where's the next point? Is this one. Goes to this point. Then goes to 0, then goes to 1. So it will be like this. Like that. Are we all together there?
Yes,
Ma'am,
ma'am.
how many hours is the exam
2 hours.
without the use of a calculator?
Yes, that's what I'm saying. Your brain needs to start working. I'm not missing anyone here, right?
Yes.
Thank you. So I'm moving forward. And that's part of your assignment. So then you have that. Remember, they said our function must be written like this. So that's why we had to rewrite it like this. Well done. And then we amplitude is 3/4. Our period is 5. Our phase shift is B. Well done. Shift to the left. And then here, our appropriate interval is what we got. And there it is. Your theirs looks nicer than ours, but it's fine. Do you see that? So do you see that it was shifted horizontally to the left? That's the phase shift. We're not doing this section. So this is the end of for this particular section. Any questions before I stop the recording? Alrighty.
Thank you.
Alrighty.
Ma'am, can you share your slides with us?
Yes, please.
I
Cause compared
can't
to
share the
textbook,
slides,
compared to the
guys.
textbook, ma'am, the textbook is too thick. Yo.
But you know I can't share the slides.
Why not, ma'am?
No.
I can't share the slides. Let's see. Stop the recording. You see, the thing is, it's